you nearly had this XPTABLES webinar cancelled this morning. I'm on a trip up to Queensland and on my way to the location where I was due to be presenting, had to take a detour due to a flooded road. So just an interesting point there, that it does affect all of us, even those not doing any modelling at all. So for those that haven't joined us before, this is part of our XP Live educational program, and you'll find all of our previous webinars have been recorded and are available at the website up on your screen there. You can easily navigate to this from the homepage xpsolutions.com as well. We're planning for today to be 30 to 45 minutes in duration, depending on any questions we might answer at the end. And as you know, we're covering the enhancements to XPTABLES for the 2013 release. So we've split this up into 3 sections. The first section being on the updated WSUD on-site detention interface. Then we'll look at some of the user-defined file formats and rainfall improvements that have been made, and mention a few additional functions and features at the end. We've got a couple of typical models which we'll use to demonstrate some of the new capabilities. So first, the updated WSUD OSD interface. So that some of you may have used this function in the software previously. The reference for this is the on-site stormwater detention handbook, which was published by the Upper Parramatta River Catchment Trust. So that methodology is still the underlying method for the implementation in the software, but we have listened to your feedback and improved the interface so that it's a lot more user-friendly, added some diagrams so that it's clearer to understand exactly what's happening actually in the software there. So we'll go through an example as to how you can use each of these screens and then show you that live in the software as well. The other thing, as well as the new interface, is there were a few advanced parameters that could be specified numerically, and these have now been integrated in the interface, so no need to be any good at any kind of coding in order to get the software doing what you want it to do. So just a reminder of why we might want to use this. I'm sure a number of you have been involved in jobs where you're required to design the drainage in such a way that you don't create or worsen any capacity problems in the drainage system. When putting an urban area essentially in place or increasing the paved surfaces, this can be quite challenging, especially where there's a lack of space. So using on-site detention to reduce the peak flow and provide water quality benefits can be quite a good way to get the drainage included. Should note that the water quality isn't analysed in XPTABLES. This only focuses on water quantity. So what types of OSD might you use? Well, it could include water-sensitive urban design features, so rain gardens, bioretention areas, small ponds, or even rainwater harvesting. So we'll show you how to combine an on-site detention with a roof rainwater tank, but essentially XPTABLES doesn't actually need to know exactly what this system is. It just needs to know how much storage it's going to provide. So how do we access this feature? Well, if you go to the node subcatchment data dialog, you'll find that, as always, there has been a WSUD option there. This uses a global database template, which means that you can set up an on-site detention system and then reuse that all over your network. So it's very useful at the planning stage to look at how effective adding this sort of storage might be into your design. So this is the new interface now we're seeing, and we have first a general tab. So here what we're doing is we're just putting in some details about the catchment, how that's split up, how much of it is going through the on-site detention facility. So one thing that is important to remember here is that if you've got your first subcatchment and second subcatchment, that first subcatchment should be the pervious area capture, and the second subcatchment should be the impervious area. So if we think about the impervious area first, if we say got a hectare of impervious area specified, what we do here is actually say how much of that land use is, how much of the impervious area covers each of those land uses, and how much of each of those land uses is captured by the on-site detention. So in this example, we've got roof and road both at 40% and paved at 20%. And the roof is entirely being captured by the on-site detention. The road is actually not being captured at all. So this means the road area, or 40% of the impervious area, is just going to discharge directly into the node, so there won't be any adjustment to the hydrograph. The paved area is also being captured by the on-site detention as well. The reason for having the roof and paved split up is so that we can also put the roof through a rainwater tank system as well. So we'll come on to that a little bit later. Then we go on to the pervious area capture. So we don't split this up, but just say whether this is actually going through the on-site detention or discharging straight to the node. So here, obviously, we've got 100%, so it's all going through the on-site detention. Then we specify the average allotment density in lots per hectare. And this is per hectare of developable area. So these final two cells here should be looked at together. So the developed area over total area is the ratio of how much of the area contains lots over the actual total subcatchment area. And then with the lots per hectare, that tells us how many lots we've actually got on the site. The reason for doing this is so that we can actually specify the on-site detention and rainwater tanks, so that we have, say, one rainwater tank per lot, and this can be multiplied up. So we don't have to set up each lot individually. We can put in this information, as I say, at the planning level, and allows us to simplify some of the data that we enter. So then we move on to the on-site detention, and there are several types of on-site detention system that can be modelled in this interface. So we can have a rectangular or a triangular type. The rectangular type could also be circular, but essentially represents a straight-sided storage. So it means the storage is split up into equal increments as the height increases. With the triangular option, this reflects more like a natural ground-based sloped pond, for example, with the deepest part being at the outlet. So it has an effect on the storage calculation in the background. So then you can see we've got one option with HED, which stands for high early discharge, and one option without HED, or high early discharge. So the option without HED means that the discharge is proportional to the driving head of water. So the outlet, for example, at the secondary level is in between the extended detention storage and the flood detention storage. And the same for the primary outlet, it's actually at the base. If we have the high early discharge option, we have a chamber, a high early discharge chamber, which means the outlet orifice is actually at a lower level, and we can increase the head acting on the outlet at an early level and approach the desired discharge more quickly. So we'll come back to the high early discharge shortly. So here we have the interface for the rectangular option, and you can see that we've got the heights of various different requirements marked on here. So it's important to note that this allows you to have an extended detention storage so that we can control flows for the low discharges. This helps with water quality and would often be a lower return period event that we might use this lower portion of storage for. The flood detention storage would be more for the, say, the 100-year average recurrence interval, and allows us to have that additional storage for that higher event. We then have the overflow spillway as well. So on the right-hand side here, we enter how much our discharge should be in litres per second per hectare for the primary and secondary outlets. It is possible to have just one outlet, in which case we enter 0 for the secondary outlet, and then the whole storage is combined. And again, the spillway here is in metres per hectare. So these units allow us to use the tool across multiple lots. So using the number of lots per hectare and how much of our area is developed means that we can specify this for across the whole subcatchment rather than individually. We've got the infiltration option added here in 2013 as well. So this was previously an advanced parameter. Now it opens up the usual infiltration interface that you would see with a retarding basin to allow you to specify infiltration on this on-site detention as well. And finally, we should just mention that the volume of the initial water divided by the total volume of water storage at the start can be entered as a percentage. So we can have this OSD part full. So we can represent if there was already some water in the system. It's perhaps less common to use this on OSD, but is often used on rainwater tanks. So we'll see it on that option as well. So the triangular interface is very similar, but just shows the measurements all on a triangular based storage option with a sloping side. So we've run through these options on the interface for extended detention storage and flood detention storage, but I didn't mention that the site storage requirement should represent the total volume. So this is for the overall storage, which would then be partitioned into the extended detention storage being the lower part and the flood detention storage being the upper part of the storage there. So these definitions will be available in the help file and also obviously in the recorded webinar after this event. So again, we've run through these actually in the interface, but I've just included those definitions there for you so that you can reference back to this presentation if needed. So just to come back to the high early discharge option and how it works. So these diagrams here show us going from an empty high early discharge chamber to what happens when that actually fills up. So the first stage is that discharge chamber fills, and then once that discharge chamber is full, we obviously have quite a large increase in the head of water that's acting on the outlet, so we can get more flow going through our outlet faster than if we didn't have the high early discharge chamber. Of course, that then overflows into the main storage, and then when both the high early discharge chamber and the main storage chamber are full, the storage and the chamber both empty, and we have the flap valve there to allow that to drain through the high early discharge chamber. So with that high early discharge option, the maximum discharge is reached very quickly. If we don't have that option, the discharge rate is progressively increased up until the allowable discharge to our maximum water level. So the roof rainwater tanks can be included as well. This is optional, so we could have just on-site detention. But if we want to also have a rainwater tank, we can enter a percentage roof capture into this interface as well. So if, for example, we had 100% of the roof on the general tab being captured by the on-site detention, and 100% of the rainwater tank specified for roof capture, the water would go first through the rainwater tank, then it would go through the on-site detention for the roof area. And this roof rainwater tank can represent a rainwater tank with or without an outlet, normally say partway up the tank, to provide additional airspace that we know will always be available for storage. So typically we have water space available which is drained via uses in the house for toilet flushing or watering the garden. But if we want to use this almost as an additional on-site detention storage option, we can have an additional airspace available at the top and an outlet. So again, we've got the volumes here specified per lot to allow us to multiply this up for several areas, and then the discharge in litres per second per hectare. Of course, we have an overflow spillway, which will just take the water straight to the node, and we've got our dimensions here specified on the tank. Again, we can fill this from the start, so we could, for example, have the tank set at 50% full from the start, which means that we're going to have only half of our total volume available for storage, and that means that we're perhaps simulating something closer to reality. You may also find there's local requirements that specifically dictate how much storage is available, so that can be used to try and meet your local conditions. So we've run through the definitions there, but they'll be included for you if you'd like to download the presentation afterwards. And I'll just skip over those as well. So now what I'm going to do is just open up a model here that we've got, which has some on-site detention specified. So simply on the node we have the sub-catchment data and we have the WSUD on-site detention option. So when we click on this, we have our global database screen that we're familiar with, which we can edit, and then we have the new interface. So we can now just enter the data or review the data that's already there and see that we've split up the impervious area and specified how much pervious area is going to be captured here, and then entered our on-site detention details as we've already shown in the presentation. The same for our rainwater tanks. So at the moment there's no rainwater tanks here, so we could set that to 100, and that means that the roof area will now go through the rainwater tank before it discharges into the on-site detention. If we wanted to discharge the rainwater tank after the roof area after going through the rainwater tank directly to the node, we could simply set the on-site detention capture for the roof back to 0. So you've got the flexibility there to set it up as you want. So it's very simple to use in the interface, and hopefully you'll now find with those improvements that it's a little bit easier to understand what's going on there. So we'll talk about some of the other additional improvements. Again, we've been listening to some of the requirements and suggestions from you are our users, and one of them was to add some additional storms, additional AR&R storms to the automatic storm generator. So you'll now find that the 270-minute and the 540-minute storm can be added to the storm generator there. We've also been investigating what the options are for when you're working with average recurrence intervals of more than 100 years and less than the PMP. So these are often referred to as large to extreme storms in the Australian rainfall and runoff guidance. There hasn't been any clear guidance on exactly what the temporal pattern should be for these, but it does suggest that the PMP pattern may be more appropriate than the AR&R 100-year pattern. So previously there wasn't a choice in the interface, and now we've given you the option to select whether you use the AR&R 100-year temporal pattern or whether you use the PMP temporal pattern for those large to extreme events. So I'll show you how you can add that in. We've also enhanced the rainfall option for loading in your own rainfall data. So for a long time it was only possible to load Hydrographs storms or just to type in XPTABLES storms and just type the data in. So now we've got the option for a user-defined storm, and this allows us to set up a user-defined file format. So this user-defined file format means we can read a whole range of different files, mostly text-based files, CSV files, Excel files, and so on, and load in whatever kind of rainfall data you need to. So again, we'll run through how to set that up in the interface. This functionality has also been extended to gauged hydrographs. So the Hydrographs hydrograph file format was previously available, as well as the Rafts hydrograph format. But again, we'll now be able to load text-based files, Excel files, and whatever file format you've got set up just by setting up what order the data is contained in there. So I will go back to the software and show you how to set that up just with this gauged hydrograph example here. So this is a simple river example, and on this node here we've got both a gauged hydrograph and we also have a local storm specified. So we'll start with the rainfall data first. So if we click on the local storm option, we would need to specify the user-defined storm and just set that up there. So we could add a new one here and just add that and click on edit, and then we could locate the file that we want to load. So we're going to be looking for a rainfall event, and then if we just open that rainfall event in Excel, we can have a look and see what the format is. So here's our rainfall event. We've got 3 columns. The first one is the date, the second one is the time, and the third one is our rainfall data. So what we need to do here is we'll set up a new file format, edit that. We'll check how many header lines we've got. So 4 header lines there. So we set up 4 in our header lines. It's a free format CSV file. And then we simply put in the columns we've got there. So we've got date, day, day, month, month, year, year. And then the hours and minutes, and finally the rainfall. So if we say OK, click on select, we can just click edit to check it's reading that file correctly, and then OK, and we can select our user-defined storm. Okay, so then we can do something very similar for the gauged hydrograph data. So again, if we select our user-defined hydrograph, we can set up a new hydrograph there, click on edit, load our hydrograph file. We'll just have a quick look at the hydrograph there, and this time we've got 3 header options and 3 similar columns. So we'll do new gauge, edit that one, enter in our 3 header columns, the free format CSV, enter in the date, the time, and then the flow data this time. So once we select that one, so then our gauged hydrograph data is loaded in. So in this file we have some automatic storms specified, and here you can see we now have those additional storm durations included. So our 240 minute and the 540 minute, which were previously not available. We've also got the additional temporal pattern in there. So if you click on Insert and enter the additional return periods, you can see that for anything between the 100-year and the PMP, we've got the choice of which temporal pattern to use there. So just a little drop down for you. Okay, so just to a few other improvements that we have got in there. Some of you may have previously used the total and local hydrograph export options. We had a few issues in 2009 and some of those weren't working correctly. So we've now got the total and local hydrographs fully working, and you can export those on all nodes with global storms. There's no limitations on the combinations there. The other thing we've done is just to make a simple change to the file format to make it a little easier to get from exporting the INT file for loading into XP Swim and Storm. So I'll just show you what it is you need to tick on to make sure that happens. In XPTABLES, copy and paste now copies all the data in without the need to save the model. So that's a lot easier to use and should be a lot faster for entering your data. And then we've also updated some of the dummy link data. In XPTABLES previously wouldn't actually transfer through to the model. So you'll see that all of that data now actually affects the results in the model. Just a reminder as well, we've built a new installer for the probable maximum precipitation grid files, and through training courses and speaking to a few people on technical support, we realized not everyone was completely aware that that function was available. So we have some grid files that go with the probable maximum precipitation that allow some of the variables for the GSAM method to be automatically populated. So what you'll need to do is make sure you're registered at our new support portal, support.xpsolutions.com, and if you're already registered you can simply log in. Then you can go to the download section. This is what you'll see when you log in. There'll be a section on xprafts and you can download the PMP grid installer. The reason for this is in the PMP tab we've got some catchment adjustment factors here, and some of these can be automatically read when you have those grids. It is worth noting that it may not be always appropriate just to read those based on the simple catchment data you have, and you should always refer back to the actual reference for probable maximum precipitation, and make sure what you're choosing for your catchment is appropriate. You might have part of your catchment, for example, in one area and part in another for those particular factors. Okay, so just a couple of quick things to show you in the software there. And first of all, I'll just show you a reminder of what you need to do in order to export the interface files if you wanted to take hydrograph data into XPSwim. So in the configuration job control, you've got the hydrograph export option here. So you tick on the XPSwim XPStorm format, and you'll find the XPSwim interface file there now. It's the same file format as the xtran file, but if we just now export in the interface file, it means you don't need to change any file formats, and it'll just read directly in there. So we can save that file. In order to make sure that's actually populated with the data, you should make sure your output control is on full, and make sure you check on the XPSwim options in the hydrograph export there. Just a few of you again on support not following those options correctly. So we can close that one and just have a look back at our PMP example. And again, just a reminder that once you install those grid options, if we go to the job control and the automatic storm generator and click on the PMP option, it's in the GSAM option here that we can use the compute to read the values from the grid if we've got those grids installed. So they are worth downloading. So just a couple of final things to run through. You'll find some improvements in the installation process. There's a new interface to guide you through that. Administrative permissions are no longer required. We know that some of you were having issues with installation because of that. And so that will now be working fully in Windows 7 and Windows 8, and has a couple of fixes in for using with Windows XP with the 64-bit option as well. I also wanted to mention, for those of you that haven't come across our new support portal, that we have a new address for support, which is support.xpsolutions.com. And those of you with expert care will now have access not only to your usual support team, where you can upload files and log your queries. All the downloads are also contained in this place, but there's also a vast knowledge base there. So it may be that you can get a faster answer just by searching the knowledge base rather than waiting for someone to get back to you. If anyone is interested in evaluation, demos or quotes, please contact us on our sales email address there, and if you're out of maintenance, we can give you an expert care quote there too. And if you've got ideas for future webinars you'd like to see on xprafts or any other topics, please send us your suggestions. That's the end of the presentation. My contact details are there if you've got any additional questions. Thank you for listening, and hope you'll join us again in the future.